Directions for question 64. So for each diagram, if possible, find x. If triangles are congruent, state the congruence property. If they are not, right cannot be determined. So question A, first of all, do we have congruency here? And we do. What theorem is going to tell us that we have congruency? Go ahead and look. So we've got this reflexive side here. We've got these two sides here. And then we have the right angle there. So what congruency property is that? Right. And if this part is x, okay, and this is congruent to that, then this must also be x. And go ahead and consult your flowchart if you want to know how to solve this. We've got a right triangle. We are looking for a side. We know two sides, so we're going to use Pythag. Remember, for Pythag, it's always equals your hypotenuse squared, so it's going to equal 10 squared. So I'm going to do x squared plus 8 squared equals 10 squared. If you remember Pythagorean triples, this is a Pythagorean triple, so that will help you out. If not, let's just do the work. Okay. First thing is exponents, so x squared plus 64 equals 100. Subtract the 64. You get x squared equals 36. Square root both sides. X equals 36. All right, there is question A. Let's move on to question B. All right, can you prove that these two triangles are congruent? Okay. Remember, we have parallel sides. So that means we also have alternate interior angles right here. So go ahead and tell me the property that would happen for those triangles to be congruent. All right, they're going to be congruent by, so we've got an angle, and then the reflexive side, and then an angle. So angle, side, angle. All right, and I need to find x. Fortunately, this one's really easy. Okay, if we match up corresponding sides, the side across from my double angle here is x. The side across from my double angle is 10. So these two are corresponding sides. So by CP/CTC, I know that these are congruent. So x has to equal 10. No other work to do on that one, which is nice. All right, question C. All right, I'm not going to ask a question on this one, but how is this one congruent? And the actually easiest way to do it is congruent by HL. We haven't used HL a lot, so I'm just going to point it out. So first thing we need is right triangles. We do have right angles, so we've got right triangles. The next thing we need is the hypotenuses to be congruent. Well, this hypotenuse is congruent to that hypotenuse because it's reflexive. And then the last thing we need is a leg, or a side of the triangle, to be congruent. And we've got this one is congruent, so AD is congruent to BC because they're both 11. So we do have congruent by HL. It also means that this one then, by CP/CTC, is congruent to AB. So this is X. If I've got a right triangle, I'm missing a side and I only know one side. The easiest way to do this is going to be to use a trig function. What trig function is going to use one of these two sides? That'll be tangent. So we're going to have tangent, you can see that. So tangent of 35 is going to equal the opposite over the adjacent. So equals 11 over x. Put it over 1. Go ahead and plug that into your calculator, the tangent of 35. That's going to equal 0.70. So 0.70 over 1 equals 11 over x. All right, we can cross multiply. We get 1 times 11. It's going to be 11 x, and then 0.70 x over here, divided by 0.70. When you put that into your calculator, you get x is approximately 15.71. And last one, question D. So we know AC and BD are straight line segments. So that tells us that we're going to have vertical angles congruent. So do we have congruent triangles? And the answer for this one is no. Because there is no angle, angle, angle congruency. There is angle, angle similarity, but no angle, angle congruency. So we can't prove it, so we cannot solve for x here. So that's the end of that question. Go ahead and let's finish this up with question 65 on the next video.